Here in example 4 from the chapter on Laplace transforms, we're actually given the Laplace transform of the response. We're calling this capital Y of S, is as shown as this a fraction. And from this we want to find out what the steady state, the long time value is of Y of t. We're going to use the final value theorem. One thing we need to recall from this is that the final value theorem will apply here only if the roots for the denominator d of s, these roots, we'll call those P1, P2, and P3, since it's a cubic function of x, has non-positive real parts. In other words, before we apply this, we need to look at d of s right here. First find its roots and then figure out, based on that, whether we can even apply the final value theorem. So d of s, which is equal to s times s squared plus 4s plus 5, those roots are found by setting d equal to 0. So we solve this, and although it is a cubic function in S, well, there's one of them that we know. The first one, P1, is 0. The other two, 2 and 3, P2 and P3, we find from the quadratic equation. So that's minus 4 plus or minus the square root of 4 squared minus 4 times 5 divided by 2. And so those two roots, those two poles here, are minus 2 plus or minus j. So from this we get what we need here, in that the roots have negative real parts. Conclusion, we can do it. So therefore the final value theorem will apply here. So what we have then is that the long time response, y of t, which we know from the final value theorem, is taking a limit as s goes to 0 of s times y of s. That gives us the final value for y. So what we have then, therefore, is the limit as s goes to 0 of, let's see, that's going to be at 10 s plus 3 divided by s squared plus 4s plus 5. The s in the denominator d got canceled out by the s that we multiplied through. It's easy to take s equal to 0. We lose these terms here. And what we get, therefore, is that we get a 30 divided by 5, so that's 6. So this is the value that we know that y is going to have for a long time. And this is a fairly powerful tool to use. We didn't actually have to find the response y of t to find this out. However, in example 5, we do find it. So what I would ask you to do is to go back when you get through with example 5 and look at those examples, that example, to confirm that that's true. That is, when you look at the final result that we get for y of t from this transfer function, or this Laplace transform of y, we can look at that and tell that truly that the final value is S. The point being is if you don't really want to find the response, but you want to find out what it is in the steady state case, you don't have to go through and find the response. You can simply apply the final value theorem, provided that the roots of D abide by the condition that they have non-positive real parts.